You know when you see a cool new study in the news, we always jump to the big, flashy conclusion, right? But what if I told you the most critical part of that research, the part that decides if the results are even real, happens way before any headline gets written? It's this hidden, intense process, a kind of gauntlet every researcher has to run. And today, we're going to pull back the curtain and see exactly what that looks like. So what is that all-important behind-the-scenes process? What exactly happens to all that raw information a scientist collects before it gets turned into a finding that you and I read about? It seems like a simple question, but the answer is, honestly, one of the most important things to understand if you want to really get how science works.
Well, the short answer is the data gets cleaned. But hold on, because that word cleaned is a massive understatement. This isn't just about tidying up a spreadsheet. Data cleaning is this intense process of making judgment calls, fixing mistakes, and wrangling messy, real-world information. The choices a researcher makes right here can totally change the final result. It's not janitorial work. It's more like architectural work. They're literally building the foundation for the entire discovery.
All right, so today we're going to walk through this whole researcher's gauntlet. First, we'll talk about why cleaning data matters so much in the first place. Then we'll get into the two big technical headaches, what to do when you have missing data, and how to deal with those weird data points called outliers. After that, we'll explore a really fascinating ethical trap called HARKing. And finally, we'll give you the tools you need to become a much smarter, more critical reader of research yourself. Let's do it.
Okay, let's dive right in with the most fundamental idea. Before you can do any fancy analysis, you have to prepare the data. And this isn't some optional little warm-up, it's everything. It's the bedrock of the whole study.
You know, we kind of have this idea of raw data, right? Like it's this perfect, pristine thing that researchers just download and plug in. But that's a total myth. In the real world, every single data set, whether it's from a survey or a lab or company files, it's messy. It's got gaps, it's got typos, it's got all sorts of weird surprises. So preparing the data isn't about cheating, it's about making it make sense so you can get an honest answer.
So, what's the very first hurdle a researcher has to deal with? It's a problem that plagues basically every single study. Missing data. You know, someone skips a question on a form, a sensor fails, a record is lost. Gaps are just a fact of life. So the real question isn't if you'll have missing data, it's what in the world are you going to do about it?
And here's the thing that really matters: transparency. A great researcher doesn't just quietly fill in the blanks and hope nobody notices. They have to document and justify every single decision they make. They need to tell you exactly how they filled those gaps, what assumptions they had to make, and if they had to kick anybody out of the study because of it. Explaining the why behind these choices is what separates rigorous science from sloppy guesswork.
And let me give you a real-world example of what this looks like. So, in one study, researchers were missing IT spending data for 39 companies. What did they do? Well, first they tried to find it elsewhere. No luck. So they made a smart, logical choice. They filled in the blank with the industry average for that year. The key is, they didn't hide it. They wrote it down clear as day so anyone reading could understand and judge their method. That is what good science looks like.
All right, so you've patched the holes. But then another beast comes out of the woods: the outlier. This is easily one of the trickiest, most debated challenges in all of data analysis. It's that one data point that's just way out there, and what you decide to do about it can literally make or break your entire conclusion. So what even is an outlier, really? Simply put, it's a data point that is way, way different from all the others. Think of that one house in the neighborhood that's a literal castle, or that one day in July it decides to snow. For a researcher, the million-dollar question is always, why? Is that point so different?
Now, this is super important. Not all outliers are the same. They actually come in three main flavors. First, you've got your basic error. This is just a mistake, a typo, a measurement glitch. You fix it or remove it. But then you have an interesting outlier. This isn't a mistake. It's a real but super rare event. Think of a genius student or a breakthrough company. These aren't problems to be deleted, they're potential discoveries to be studied. And finally, there are influential outliers. These are real data points, but they're so extreme, they can single-handedly drag your results one way or the other.
And we, as a culture, are totally fascinated by these interesting outliers, right? I mean, Malcolm Gladwell's book, called What Else? Outliers, was a #1 bestseller for 11 weeks straight. It just goes to show that these unique cases aren't just statistical noise. They often hold the most important lessons if we take the time to understand them instead of just deleting them. So because you've got these different flavors of outliers, a good researcher can't just wing it. They need a system, like a decision tree. First, you find anything that looks like an outlier. Then, you play detective. Is it just an error? If it's not an error, could it be one of those really interesting cases? And finally, you have to check if it's having a huge influence on your bottom line. It's an investigation, not just a simple choice to delete or keep. Okay, so far we've talked about the technical stuff, the mechanics of cleaning data. But now we're going to pivot to something a little different, something more psychological and ethical. It's about the intense pressure on researchers to tell a clean, simple story and a dangerous temptation known as HARKing.
It's a practice called HARKing. That's HARKing. It stands for hypothesizing after the results are known. Basically, it's when a researcher finds something surprising and unexpected in their data, and then they go back and rewrite their whole introduction to pretend they predicted it all along. It's like shooting an arrow at a wall and then drawing the bullseye around where it landed.
Okay, to make this super clear, let's imagine two researchers. First up is Penny Predictor. She's doing it by the book. Based on existing theories, she predicts that a certain personality trait will be linked to people leaving their jobs. She goes out, collects her data, runs the numbers, and boom, her prediction was right. That's textbook science.
But then we have Annie Accommodator. Her original theory was about something totally different, but as she's poking around in her data, she stumbles upon that same unexpected link Penny found. Instead of reporting it as a cool, surprise discovery, Annie goes back and rewrites her paper to make it look like this was her brilliant prediction from day one. Annie has HARKed. She accommodated her story to fit her results.
And you might be thinking, okay, but who actually does this? Well, a lot of people, it turns out. One study was pretty shocking. It found that 34% of scientists admitted to doing this, to presenting a surprise finding as if it was their original prediction. That shows this isn't some rare fringe problem. It's a big deal, and it's often driven by the publish-or-perish pressure to have a perfect story.
Now, just like with outliers, not all HARKing is created equal. It's a spectrum. On the less problematic end, you might have a researcher who just adds a new theory to explain a cool finding they stumbled upon. The issue there is more about a lack of transparency. But on the far more problematic end, you have something called question trolling. This is where someone just goes on a fishing expedition in their data, looking for anything that's statistically significant, and then invents a story around it. That really undermines the whole scientific process.
Whew! Okay, so we have made it through the gauntlet. Missing data, tricky outliers, and the temptation of HARKing. So, what's the takeaway for all of us? How can we use all this inside knowledge to become smarter consumers of science?
Well, all this gives you a toolkit to be a much more savvy reader. Here's what to look out for. First, use Occam's razor. If the theory in a paper seems ridiculously complicated, it might be because it was cooked up after the fact to explain a weird result. Second, have some healthy skepticism. If a study seems too perfect, where every single prediction works out, be a little suspicious. Science is messy. Third, check for transparency. Do they explain how they handled their missing data and outliers? And finally, the gold standard, replication. A finding is most trustworthy when other independent scientists can do the same study and get the same result.
So from now on, when you see that big, flashy headline, you'll know about the hidden gauntlet the researchers had to navigate first. You'll know that clean results don't just happen. They're the product of dozens of tough choices. And knowing about that process, the challenges, the decisions, the temptations, it really does change everything. The goal isn't to make you distrust science, not at all. It's to make you a smarter, more engaged, and more informed part of the conversation.